Okay. Back again. I'm doing some more work on the the ST7735. So the other day I streamed this, and one problem was I didn't know what pins I was working on. It just seemed like a mess. So I got it working, which is pretty cool. I'm gonna open up Fani and get my little setup going here. Awesome. So let me get to the left screen. So this is what I have so far. I'm going to plug in the USB. The screen is kind of somewhat upside down. I do not care too much to try to fix it. There we go. I'm going to lower this to the screen because we're going to want to focus on it. There we go. It's like super close. It might not want to be in focus. It's a little too close. Don't know what the focal distance of that. This is just a cheap webcam. Okay, so we have that up and running. Now let's go to our 4 quadrants. So I'm going to get this somewhat set up for us. So that way we can see the screen. And we can do some coding. I really enjoy Micropython. I probably say this every day, but every stream. But Micropython is just so darn useful. Okay, so we're going to connect to the interpreter, or we're going to REPL into the board. Again, I don't know what that verb is, but read, evaluate, print loop. I was working on a library where I'd actually redirect the standard output of MicroPython, and I've made my own kind of REPL. Board not found. I hit stop and restart. Oh, there we go. So popped up. So there's a tutorial I just uploaded, and I go through how to connect these with wires. The craziest caveat is that on that video is that in order to find these two pins, SDA and SCK, the library, the MicroPython library, just doesn't specify that in a variable because those two pins can be found on the board itself. And how I did that was by going to import machine. And it's already imported into this, but and then from import machine, I went to print and machine.spi and the first SPI. And so it did clear the board here, but it tells us what the SPI connection is, and the SCK is 7, the MOSI is 11. So those two values are the ones that we care about. So those two pretty much have to be the pins that we use. I think we can specify this and change it to whatever pin we want to. But from the documents I read earlier, that would end up with a slower connection, so to speak. And since this is a display board, we want to do cool stuff with it, right? Oh, and I didn't set up my 4 quadrants. By the way, where is my 4 quadrants? There we go. Oh, my stream deck. Okay, so what we have here is some code. It's doing this print, this test print. I'm using it just as dummy code right now. And I might see if I can put on a little bit of music in the background. And I don't have anything specific. Okay, I'm just gonna leave it blank for now. Hopefully, you guys can entertain yourself with audio. What I am gonna do though is attempt to see if I can start. I need to pull from GitHub my task force AI, and of course, I just realized I can't do that because it is what it is. Doesn't matter. So what they're doing is they're defining print test. This is fine. We don't really need it. We have some stuff on the board. Modify this. This is user defined pins for connection. And I'm going to put a note here that SDA and SCK are defined in print machine SPI1. SDA equals MOSI. SCK equals SCK. And I'll capitalize those because that's the naming convention I usually use. SCK, SCK. Ah, that's funny. I don't know why my brain went to a different letter there. Alright, so pretty much this is all we need from boot. It's just going to import what we need. SST is an actual file. So this is what's cool. So Micropython, one of the reasons why I love it so much is you can do this. You can literally import a driver as a file, and just like normal Python, hit import, and as long as it's in the same directory, it works. With files, with folders, I do believe that works too. I don't go that nerdy. I don't know what word to use with MicroPython yet, but I do hope to in the near future. So okay, I'm gonna just stop and restart this board. And every time you start and restop this, it should run just whatever is in boot.py. This is MicroPython's de facto file to run. Main.py is for CircuitPython. But the reason I don't like CircuitPython is a lot of things are compiled for it, which, I don't know, it kind of makes or breaks it. I just love the fact that the source code is on the board. And that just reminds me of programming with normal Python. So I literally can unplug this ESP32, plug it into my friend's computer, and download the code from it and modify it or play with the REPL environment. So what we're going to do probably a lot of today is play with the REPL environment, so much so I'm going to do a new window capture. And this is going to be Thani. And it sees Thani. Perfect. So if I shrink Thani to a decent proportion, it should scale it up quite nicely for you guys. There we go. That's decent. All right. So this is our little environment we have. So first off, we've already loaded this from ST7735. We've imported TFT from sysfont. So we have one font available from machine. Yeah, these SPI and pin. We have time, we have math. GC is interesting, this garbage collector. And then let's do dir. Dir GC. What's inside of GC? So if you want to look what's inside of something, this REPL environment is really cool, I think, because we are just pretty much on the board right now and communicating with it. So we're asking it, help dir. What is the dir? It's a type of function. Okay, help dir. Anyways, yeah. So there's some like recursion thing going on there. But dir pretty much will tell you kind of what's inside of an object. I don't know how to describe it. I'm probably not the best, but look it up. So the three ones, dir, locals, and globals. I don't ever really type that into the REPL environment, because if you type in local or globals, it will pull so much information. You're gonna run into some issues because of the nature of this REPL environment, how we're interacting with the Python. Um, Interesting things happen, but for the most part, we can hit dir, and what was I trying to do? GC, yeah, GC, garbage collector. So GC collect, GC enable memory allocation, memory free. Yeah, so GC dot mem free. So this is, oh, GC, I forgot to open and close brackets. So this tells us how many memory, how much memory is free. And then GC mem allocated is, that's how much memory is allocated. So um, free equals GC dot mem free. Um, Taken equals GC dot mem allocated. So what is free? Uh, ah, What's taken? So that's the total memory, which should be 2 MB. 2 0 0 0 0 0. Yeah, so 2 million bytes. Um, that's at our disposal. There's a little bit more. Actually, what is that? So, because back in the day, and so I always say back in the day. Please forgive me. When I was younger, when I was learning about computers, they said that a kilobyte is actually not just 1,000 bytes; it's 1,024 bytes, um, because base two system. I am not sure. So what is 2 to the power of, what would that be? 2 to the power of 15? Ah, to the power of 25, 24? No, no. See, I'm like super off on this. Yeah, I should know roughly. So 1 2 3 1 2 3. Okay, so it's 2 to the power of 20, 21. Yeah, so 21 is 2097152, which is pretty darn close. I'm curious exactly why that is more than 2 MB, but if you guys know, let me know. You can't clear the screen, can you? No. CLS doesn't work in this situation. You need to enter a whole bunch of times, get some spaces, and confuse the REPL environment, which I just did. So this is what's interesting is what the heck? So with MicroPython and the REPL environment, so it's communicating over USB to the computer. And there's some back and forth going on that is hidden from this. And one of the things that's hidden is that really the REPL environment is taking a global list and a local list. So you can run into some interesting problems that I need to create my own software. I wanted to create my own REPL software, just so that way I can understand what's going on in the whole process. It is time consuming, but I have run into a few times where a variable will stay in memory, and I'm like, how in the world is this saved anywhere? And I've noticed that the ESP32-S2 chip seems to store the SSID somewhere that seems magical. It will pop out of nowhere and it will remember an SSID for Wi-Fi, which makes sense that the board was primarily made, from my limited understanding of the expressive chip, that it was made for Wi-Fi connection and things of that nature. So maybe how it handles that memory gets tucked away somewhere magical that I'm not aware of. But we're playing with the board. So tft.text. We might want to maybe I kind of want to write myself a little library, but let's just first write something to the board. To 0, actually text.fill, and we're gonna do tft black. So that made the screen go black. Perfect. Now tft.text 0. We're gonna say hi YouTube live. I think I have enough characters there. Hi YouTube live. tft.white. And then I'm going to need what? Oh yeah, sys font. So it's sys font and then 1. Okay, I kind of want to get rid of this left side. Okay, so it printed that to the screen. Nice. We're going to get rid of the object inspector to give us... Actually, I should... Yeah, there we go. Okay, so TFT screen, that works. So TFT.text, we're gonna do 0, 15, 18. So this should be down because top left should be 0, 0, and bottom right should be the max, which is 160 by 128. So 128 across by 160. Hi YouTube, but please like or sub, I guess. TFT, this time we'll do orange. Do they have, they probably don't. I'm just gonna do blue. Sys font 1. Oh, cool. So it isn't quite that visible, but it is okay. So I want to do a little bit of, so the library does a good job. It's communicating with the screen, but I want to be able to write to it a little bit quicker. So I'm going to define, I want it to be like a command line prompt. That's usually the first thing that I program anytime that I'm working with a board. And I usually call it frint, and it's just out of habit. So I'm going to define this called frint. And inside of frint, right, I think I can just, do I have to declare it? TFT dot text 0, 0. I need another bracket. 0, 0. Text TFT dot white. Sys font 1. Okay, we're gonna save that. But beforehand, we're gonna do tft.fill, tft.black, and we're gonna save it, and we're gonna run it with F5. And it still has this lorem ipsum on it, so we should print hi there. Okay, so it does. It automatically snags. And this always kind of weirds me out, the fact that a function can grab something that's outside of it. But anyways, it is what it is. So we're able to fill it, and then we write the text to it and continue. So there's a built-in wrapper, and they did this inside of the graphics. So test fast lines, test triangles. Yeah, here's the print test. No wrap equals true. So it looks like it's going to wrap around no matter what, unless we have this no wrap equal true. So I think that's all the variables, TFT text. We'll look inside of SST7735. So it's the init, size, RGB, rotation, pixel text. So position, string, color, font, size, no wrap. Draw text at a given position. If the string reaches the end of the display, it is wrapped at position 0 on the next line. A size width will formally. Oh, okay. So they're kind of doing this a bit. Draw a character at a given position using the given font and color. Okay, okay. That should be enough. So I'm going to put this just as my reminder of what's involved. But wrap text. So let's do higher. Even though we changed it up there, it's not going to actually be on the board. Because if I type in this section, I have to write this file to the board before it does anything. So I want to see how, what, why things happen, maybe, or whatever. There we go. So it just wraps it. And how does it wrap it? And can I get the data to where the cursor is now? I might have to build, how does it know? If size 0, that's character, define text. Let me, a size be integer, which is size font uniformity. So if float position for string, self character, if position width, no wrap, break. So it breaks if it's not no wrap. Py plus equals the font height plus the width of 1 plus 1. WH. What is WH? We check rather. Da, da, da. Okay, so it looks like I can't get to that variable. Maybe I can. No, I really don't think. Okay, whatever. So I don't. I was trying to see if I could get to the line break, but it's checking to see if it's the end. dir. There's no way to get to it. But how does it calculate if for C in string, if px plus width is self.size? So self.size. If the pixels plus the width, self.size. So that would be tft.size. Okay, so I can calculate the width of it. Width. I don't know what I want to do. How I want to do this. Because different characters might be different sizes. Because I don't think this. It does look monospaced, doesn't it? But the sys font, I know how wide it is. It's 5. So I'm gonna cheat. I'm gonna cheat. So it's 5 times the character. Okay. So length, text length equals length of text times 5. So this is fun, isn't it? I'm going to define a variable. I usually call it RAM. It's not a really good idea, but I'm just going to say that it's RAM. It's actually the history. So let's name it history. So it's the history of things printed to the screen. So I need a running total of history. So we are going to do history dot append, and we're going to add text. Text equals the str of text, just in case it isn't a text. And then we're going to have a conditional if text. Here's a very fun, this tab works in this instance, but if you use other environment, shift close bracket will indent or control close bracket in some Python coding environments. Before I knew that, I wasted a lot of time. Okay, so now if text equals the string of text, because Python is cool and you can do whatever. History.append text. So we're gonna add this to the history. Actually no. We can't do that yet. Text length equals length of text times 5. This is assuming we're keeping this 1. So I have to modify this later. History.append text. If text length is less than tft size, and then we can ask it for the horizontal, so that's 0. Can we do that? Can I do this? Oh, tft size 0. I'm pretty sure I can. Yeah, there we go. So if text length is less than tft size 0, history.append, else for loop, trying to pass it. I feel bad. This is pretty darn boring, but this is what I usually do when I program. So history, if it is longer than history, I'm going to split it into sections. The best way to do this is probably to split the text with spaces and then try to break it with spaces. But since we're just going for a straight up character by character look at this, we should just split it up every time. Yeah, that's what I should do. So for every time, if text length is less than tft size 0, history.append text. Else for while text. So while text is still there, history dot append, and did the board? Oh, it just exited with an error code. Lovely. Okay, so while text history append, text and we want up to tft dot size 0. The int of tft at size 0 divided by man, I'm having a brain fart. It's 128 pixels wide, however many characters. So you divide 128 by 5. And you want it to round off, which usually the integer does in Python. Okay, so that ends there. TFT, yeah, this is just fine. The int. The int of TFT size divided by, yeah. So this colon just means uh, all of whatever is inside of text up to that point. And then text equals, this is not an efficient way. Text and then I want it to everything afterwards. And I don't think it does the first one. Is that the case? This is horrible. Okay, backend is not ready. Sure. So let's reload it. Luckily, since it's still on my computer, I can just throw it onto the board. Okay, so I'm gonna save it. Else while text, text equals there, and it will always equal the end. But I don't like this because it's gonna get caught in this forever end loop. I'm just going to take this. Else, I'm just gonna leave a placeholder. Um, meh equals this. Okay. Actually, we don't need to because all we need. Yeah. I'm overthinking this. If text string text length 5, if text length history append text. Else meh. Hmm. Nope. You know what? Just gonna keep it simple. Gonna go back, Shift Tab. So clear the screen with black. We'll just leave this for now. Hit save. Make sure it still works. I won't waste. I'm gonna copy some boilerplate code that I had. Okay, so print hi. Cool. Print this is cool. Before I do something that I have done quite a bit in the past, something called print. Let's see what other graphic tests we can do. So there's test main. Actually, let's just run graphic test. What does graphics test do? So print a whole bunch of stuff in different colors, draws some lines. Pretty slowly. I wonder if there's any time.sleeps there. And from the other side. Print test. There should be some round rectangles. These are just the print lines. Yeah, so the circles and the other things are pretty fast. This one's pretty slow. Okay, triangles. And that's the end of it. Yeah, test triangles. Oh, time sleep in between. TFT yellow, TFT purple. There was on the actual website or the GitHub page. There was. So this is the first one. They also have this test BMP. So I want to download it. Oh, of course, they have this one. Of course they did. What's their name? Boo Chow. So that is for those who don't know the image, I think that image is one of the most popular images in computer science. There was a group, what is the standard computer science images, one that is banned. Yeah, so this image was a very popular image, so I'm kind of glad uh, that it came up because I guess it's art, but it's called Lena or Lena. It's a standard test image used in the field of digital image processing. Started in 1973, but is no longer considered appropriate for some. Uh, so yeah, why is it not allowed? Uh, Consent ethics required. Yeah, it's a step to help women feel free, more welcome in tech. Okay, sure, why not? That's just a Google answer. But yeah, we just saw on screen this super small image, which the bottom is usually cut off for uh, whatever reasons. So yeah, that was Lena that popped up. So that's actually pretty hilarious. Our test image of Lena. Um, yeah. What is this? TFT BMP. So what is this? So this one looks like it should load the test BMP. Ah, scheiße. So I'm going to copy the contents and we are going to paste this into a new um, Thani file. So I'm going to go File New, paste the code, save onto the Micropython device. And this is bmp test.py. And so now we need something to put. So let's open Photoshop. And Let's go back to boot. I mean, I could use that image, but I don't. It's just silly. Okay, test BMP. We're going to save it to downloads. I'm going to see if my Photoshop can even open it. Okay, come on, come on. I'll open recent. And open downloads. Test BMP. Okay. Oh, we got to go all the way to the end. There we go. Control A, Control copy. Oh, it's kind of funny that show transform scroll. And we needed background color. I have to delete this. Okay, delete. Delete layer. Yes, okay. So I thought this was hilarious. So we're going to use this image, which why not? And we need a new layer. Might as well go black. There we go. Save as, and can we save it as, no. Export, save for web. This is a BMP, no. Cancel. How do we save as a BMP? This is hilarious. Export, export as. What are my options? Where's the window? File, export as. There we go. There's not BMP. Save for web legacy? Okay, this I have to Google this. This is interesting. Photoshop export BMP. File save as. Oh, file save as. Save as a copy. In the BMP option, choose file save as, choose BMP from the format menu. BMP, okay, there we go. So this is, we're gonna put make it BMP in our downloads. Okay. Open up Thani. And let's open the file. Come on. Oh, you can't see this, but that's okay. I don't like it when they group things. All files, make it BMP. I don't know how I'm gonna load the BMP onto the board. Okay, so now I'm having the problem of how to load the BMP. Funny, how to put BMP file on board. I don't know if you can. Downloads? Is it gonna let me? Probably not. Look for make it. Upload. Oh, okay, there we go. It's allowing me to upload the BMP. Now I can go to BMP test, which is on there. And this is going to be make it BMP. There we go. So let's see. And let's run it. Mm-hmm. Huh. So it didn't like the image. Which is fine. Well, I might stop there, guys. I just wanted to do a little stream. Um, this is all for the ST7735. I'm not sure what I'm going to do with these, but I bought a couple of them. They cost $2. You can buy them on AliExpress, and with the ESP32 boards being only $2, it's kind of nice. One of the other things I have is this color sensor. So this color sensor is another module. Plus, I'm going to be working with the I2S protocol with some microphones, doing some interesting stuff with Fourier transforms, with speed testing on Micropython, using C-types and some other stuff. So I got a lot of videos spooled up. I'm gonna be posting those. I think one is gonna release in like 23 minutes. It's just a time lapse. But yeah, I hope everyone's doing well. Hopefully, I can make something funny, something fun with this screen. It is really fun to be able to prototype or to just make anything. I enjoy it, so I like sharing my passions, even if it's a more boring session like this, which is just poking around on the board. The more I poke around on the boards, the more I become familiar with them, and then it's pretty fun to do some advanced stuff. These screens are neat. My favorites are the SSD1306s because they're what 128 by 32 pixels. You can get them with 64 pixels too. Uh, they're fun. They're fun. All this stuff is fun. But it is late for me, so I will bid you adieu until next time, and let's see if we can make a positive difference in this world. One of the cool things is I will find out day after tomorrow if I'm in the running for the Hackaday Prize, which is kind of cool. But we shall see. So that's the 12th of June. So the Hackaday supply frame